This video covers reporting category 4, which I believe is 17.5 or 17.6. This should be 17.6. Oops. Which is reporting category 4. Reporting category 4 is all about quadratics, and there's a lot of stuff that we can do on the calculator. So these steps that you can complete on the calculator have been included in your student notes, and I will show you those steps through the calculator. So examples 1 and 2 ask us to write a quadratic function in standard form for the parabola that passes through the 3 points given. So for example 1, these are the steps they've taken to complete this problem. The first thing they did was take each of the 4 points and rewrite them with x's and y's into a table. Anytime you have more than 1 point, so 2 or more points, you can use a table. If you can use a table, then that means you can do stat edit. To use stat, we're going to put it into L1 and L2. So over on the left side with my calculator, I'm going to do stat edit, and I make my calculator look exactly like my paper. So -1, -5, 0, -4, and 2, 10. My last step is to do stat calc 5. The reason I use 5 is because they told me it was a quadratic function. So that tells me to do stat calc 5. And that is where this equation comes from. So we're going to do it together in example 2. Again, they tell me quadratic function. They've given me 3 points. The table has already been set up for us. So we are going to replace these numbers with the numbers in our new table. Remember, if you want, you can clear out anything that's in there, or just go through and replace. And I make sure that my table looks exactly like the table here. Again, I do stat calc 5 because it told me that it was quadratic. And up at the top, it says y equals ax squared plus bx plus c. Up at the top, every time you run linear or quadratic or exponential regressions, they tell you what they want you to plug in or what your equation needs to look like. So once I plug this in, all I need to do is make my equation look like the top, but replace a, b, and c with the numbers that they actually are. So a is 1, b is 4, and c is 8. And this is my full equation. So that's where those number pieces come from. For example 3, we're starting out with something similar. We start out with the table, and they give us miles per hour and miles per gallon. Part A, they've asked us to write a quadratic function that provides a reasonable fit for the data, and they asked me to round to the nearest thousandths place. So this information has already been done for us, where they took this table and put it into stat edit and ran the quadratic function. So they did quadreg, and then they rounded the numbers. If you want to pause at this time to practice putting this table into stat edit and running quadreg, that is fine. Otherwise, I'm going to move on. So this we did just like steps 1 and 2, where I'm given the equation, and we rounded to the thousandths place because when you get these numbers in the calculator, they're very ugly. So we round them to 3 numbers after the decimal. Part B asked me to predict the number of miles per gallon for a vehicle driving at 80 miles per hour. Miles per hour is an x value, so they're telling me basically that x is 80, find y. So what I'm going to do is plug my entire equation from part A into the calculator exactly like I see it. And I'm very careful with all of these numbers, all of these decimals. I make sure to put the x and the x squared in there. And in y1, I put my equation exactly like I see it. Now, if I go second table, that's fine, but remember we have an x value at 80, which means I'm going to have to scroll for a while. The other thing you can do is we have a way to do second trace value. And if you notice at the bottom it says x equals with a cursor blinking, so I can type in what I want. Now for this, when I type in 80, it doesn't work because I haven't zoomed out enough, because this only goes to 10, 80 goes way out. So to zoom out, I do zoom 3 enter, and I'm going to do it one more time just because I don't quite know. But now I can see all of this information. I can see my full quadratic that I've been working with the whole time, but we couldn't really see it up until now. Oh, sorry. So I'm going to try these steps again now that I've zoomed out twice. So second trace 1 or enter, and then I enter the x value of 80 and press enter again. And that's where this point comes from. Now the answer is the number of miles per gallon, and so they are asking for my y value, so I would write 18.4. For part C, they've asked me for the speed, which is an x value, where the mileage per gallon is maximized. So basically they're asking you for your maximum point, but they're asking you for your max x. So to find my maximum, I'm going to click zoom trace 4, second trace 4, because I have a maximum. For all of these steps on quadratics, you always move to the one you want, slide to the left, enter, move to the one you want, slide to the right, enter, enter. So my maximum is like 52.1, 28.5. Now again, they've asked me for the speed, which is my x value, so my speed is 52.1 miles per hour. Those steps for finding the maximum and minimum are listed on the second page of your assignment. So if you didn't catch all of that or didn't write all those steps down, that's okay. We have a picture reminding us of these key features for quadratics. Solutions, zeros, x-intercepts, and roots all mean the same thing, and they all mean where does this cross the x-axis. Your y-intercept is where it crosses the y. There's two different vertices that you can have. Both of these represent a vertex. This one is a maximum vertex, and this one is a minimum vertex. And then whether you have a maximum or a minimum, your axis of symmetry is always the line that goes through your vertex, and is always a vertical line, so it's always going to be an x equals. Again, calculator steps here are going to come in handy. We're going to use them in a minute. So for this part, I'm given an equation, so I'm going to plug that equation into y equals exactly like I see it. X squared plus 2x minus 3. So exactly like I see it. Now I'm going to click graph to look at this graph so I can find my key features. I can see that I'm very zoomed out, so zoom 6 gets you back to normal. To find the vertex, we repeat the steps up at the top. We have a minimum, so I will click second trace 3 for minimum. I move to what I want. My vertex is the farthest or the lowest or highest point. I slide to the left, enter, go back to what I want, slide to the right, enter, enter, and my vertex is -1, -4. That's already been written for us. I have a minimum, and the value of the minimum is -4. -4 is the y value from my vertex. My x-intercepts can be found by repeating these steps or by looking at the table. If you look at the table, your x-intercept is where y equals 0, so we have -3 and +1, and those have been written for us. If you are looking at the table and you can see where 0 would be, but it's not listed because your x-intercepts are in between some numbers, then you would definitely need to follow the steps above. Also, your x-intercepts and zeros are related. So your x-intercepts and zeros mean the same thing. Zeros is just a way of writing it without points. X-intercept, you have to write the points. Your axis of symmetry is always x equals the x from your vertex. So x equals -1 would be my axis of symmetry. My domain for all quadratics is always all real numbers. My range is going to change based on the graph. So I'm looking at a graph that looks kind of like this. My y's, I know, come down to -4. I know it's -4 because that's what's listed in my vertex. And then my y's go up from -4. So my y's are getting greater than or could equal -4. And then my x-intercept is at 0, -3. Again, we can do second trace enter. I want to know when x is 0, what's my y-intercept, and get that point. If you are given a graph and not an equation to plug into the calculator, then you can still identify these things exactly like you see them, just without using the calculator. So my domain is my x values. My x's go from 0 to 4. And because we use less than signs, we always go least to greatest. My range is my y values. My y's go down to 0 and all the way up to 5. My vertex is the highest point because I have a max. That is the point 2, 5. And therefore my maximum value would be 5 because my highest y value is 5. My x-intercept is the point 4, 0 because that's where it crosses the x-axis. My y-intercept is the point 0, 1, because that's where it crosses the y-axis. My axis of symmetry is always x equals the x from your vertex, so x equals 2. And the word 0, again, remember, just means your x-intercept as a number, not a point. So that is x equals 4 would be the 0 of the function. On the next page, we have information about the height of a soccer ball that's being kicked, and it can be modeled by the equation y equals -16x squared, plus 48x. So we have a graph over here, and they've also given us our equation. So we can plug this into the calculator and y equals to look at some information. Some stuff has already been given for us. So our x-intercepts, remember they're always number and then 0, so this one needs to be switched because the letter of the intercept is the letter where your number goes, so there's 3, 0. So if I interpret this, my x-intercepts are at 0 and 3. My x-intercepts are where my height is 0, meaning that the ball was in the air for a total of 3 seconds. The ball starts at 0, goes up and then comes back down at 3 seconds. So there was a total height, or there was height for a total of 3 full seconds. The y-intercept is 0, 0, and interpreted, this means that the initial height of the ball is 0, so it was on the ground. Or you could say the ball started on the ground because the height was 0. We have a maximum value of 36 that is found from the vertex by plugging the full equation into y equals in the calculator and finding the vertex like the steps that we showed earlier. So the maximum height of the ball is 36. Because remember, the word value means y. My y-axis is height. So my maximum y value, which means height, is 36. And then remember, you can find your axis of symmetry using the formula that is shown on your formula chart, or by finding and identifying the x from your vertex. Because we already know the x from my vertex, I can just go ahead and use that information. If I don't know that, then I have to plug into negative b divided by 2a. Excuse me. In part 2, we're asked to describe quadratic transformations. What we're shown here is vertex form, which is a parentheses x minus h, close parentheses squared, plus k. Vertex form is not given to you on your formula chart, so if it is something that you like to use, you would need to memorize it. Listed below are all of the things that A can do, that H can do, and that K can do. My best advice for you is to compare all of these to the base parent function equation, which is y equals x squared, and see what's happening. In all of these functions, x squared is listed as f of x, and then the changes are happening below. So for example 1, I have x squared for f of x, and they want me to compare it with negative x squared plus 3. Remember, the order in which your y1 and y2 pop in are the order in which you plug them in. If I switch here, I can change colors for you, maybe. Yeah. So blue is going to be my original, red is going to be my change. So there's the blue, there's the red. We can see that the red reflected across the x-axis, and the vertex shifted up or had a vertical translation up 3 units. So for example 2, in y2, I'm going to plug this in. And again, on your calculator, you're just looking for where the first problem goes in is your y1, where the second graph goes in is your y2. I think it's easier on here. When I graph them in black, they move very quickly, so sometimes it doesn't show you the best method. So when I click graph, example 2, blue is my original, red is my new. So I can see that this stretched by a factor of 2, meaning it is skinnier than my parent function. I can see based on the picture that the red is a little bit thinner than the blue, and it shifted to the left 1, 2, 3 ticks. So there was a horizontal translation of 3 units to the left. And for example 3, I'm going to plug these in exactly like I see them. I have parentheses alpha y equals 1/2 x, which is all being squared. Blue is my original, red is the new. So I have a vertical compression of 1/2, which means the graph is wider than the parent function. And we can see that the red looks fatter. So when you think about stretches or compressions, think about slime. If you put slime in your hand and you really pull it, you really stretch it, that slime is getting really skinny. But if you put slime in your hands and you push, 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 that slime has to go somewhere, so it gets really fat and fills up your hands because it has to go somewhere. Alright, the next part we have is part 4, which is forms of quadratic equations. There are two different forms, standard form, which is ax squared plus bx plus c, and then vertex form. Standard form is given to you on your formula chart, and your y-intercept is the point 0, c. So whatever c is going to be your y-intercept. You can also get your axis of symmetry from the formula chart, so all of this is on your formula chart. Vertex form is the one that's easiest for us to use for transformations, but that one is not on your formula chart. So if they ask you a question about it, they most likely are going to give you the information, like they would give you the formula, and then tell you they want you to change A or H or K. They'll tell you what they want you to change. Remember that your vertex is the point H, K, and notice H is negative in your formula, but changes to a positive. So this one changes signs. And then your axis of symmetry is x equals x from your vertex, so x would equal h for your axis of symmetry. Now, if you're asked to convert from vertex form to standard form, what you have to do is basically get everything as simple, as simplified as possible, like we reviewed the very first day. So we start by taking f of x. They've written it out for us in vertex form, and they want it in standard, which is the ax squared plus bx plus c. So we start by multiplying what's in parentheses. So x plus 1 is being squared. Anytime you multiply a letter and a number times a letter and another number, then you have to use the box. So we've used the box, x plus 1 times x plus 1. We multiply top times side to fill in the box. And then once we've filled in through multiplication, we combine like terms to find our total number of x's. So x plus 1 squared gets replaced with what it really equals, and we've made no other changes. So the next thing I'm going to do is distribute -3 times all of these pieces, and -2 at the end is not being replaced. We're not doing anything with it yet, so I'm going to rewrite it so I don't forget it. So -3 times x squared is -3x squared. -3 times 2x is -6x, and -3 times 1 is -3. So I'm just taking and multiplying all three pieces by -3. The last thing I have to do is combine like terms, and these terms over here are like terms. -3x squared and -6x do not have any other x's that are exactly alike to change them. So the only part I can change are my numbers. -3 minus 2 is a total of -5 because two negatives make a bigger negative when you add or subtract. On the last page, we're going to talk about some methods that we can use to solve quadratic equations if you don't have a calculator. So this could be they don't give you a calculator, you forget how to use your calculator, or you're given this information and no function to put into the calculator, so you can't use a calculator. So for this part with the table, if they ask you to find your solutions are the places where x is a number and y equals 0, so specifically this piece. So my solutions here would be at -1 and +1. This little device down here is something that was approved that you can put in your baggie before your EOC. And the X, the R, the S, and the Z are all capitalized. These help you know that x-intercepts, roots, solutions, and zeros all mean the same thing. They're all different words that all mean the same thing. So the capital letters help you remember x-intercepts, roots, solutions, and zeros all mean the same thing. The lowercase letters are just fillers in the word to help you remember the word exercise as what are exactly the same. So on the graph, when we're asked for solutions, as we talked about in exercise, solutions and x-intercepts mean the same thing. So this crosses at -1 and +3. So your solutions are just the point where they cross the x-axis. Another way that you could solve for quadratics is to use the quadratic formula. The first thing we have to do is set our equation equal to 0, and then we can use the quadratic formula listed here, and this is on your formula chart. So if you like this method, it's something you could use for all of these. So first I have to set this equal to 0, so I subtract 12x to get 0, combine my like terms to get -10x. Once I have that, I go in order for my numbers. A is 1, B is -10, C is -16. The quadratic formula has been filled in for us here, the opposite of b plus or minus the square root of b squared minus, so change this to a minus sign, 4 times a times c, all divided by 2 times a. So we're going to simplify. In front, we still have 10 plus or minus. On the bottom, 2 times 1 is 2. And inside the square root, I'm going to plug that into the calculator so I can see exactly what that would simplify to. So under the square root, I'm going to plug in exactly what I see, but no square root because my answers will have square roots. So -10 squared minus 4 times 1 times -16. And that simplifies to the square root of 164. Now this could be my answer. They could also give you some questions that have square roots in decimals. So if they do that and you have to take these answers and find decimals, remember that the plus or minus means you have two answers. One where you add the square root of 164 and one where you subtract the square root of 164. The only difference is the plus or minus. You would make one answer positive, one answer negative. So to show you one time how you would do that, I would do alpha y equals 10, 10 plus the square root of 164 divided by 2. So I would make my calculator look exactly like the paper, just make one positive and then do another one as negative. And click enter, and so this is the decimal 11.4. So if you're trying to use these to compare something and you see one with 11.4, that would tell you that you could use that, or that those were the same. The last way to solve without a calculator is through factoring. Now we usually use the calculator to figure out our factors, so you would use the calculator here. But if you forget your steps to figuring out like the other parts based on the graph and y equals and all that, you could factor. So we could factor our sum is 11x because it's the number in the middle. Our product is the two outside terms. You would put your product into y equals and search for the sum. So 18 divided by x, we find two numbers, 2 and 9, add up. So that's step 1, factoring. Step 2 is to set each factor equal to 0, and then we're going to finish it off with step 3 by solving both factors for x. So x plus 9 equals 0, I'm solving for x. So I subtract 9 from both sides. 0 minus 9 is -9. And then to solve for x on this side, I subtract 2 from both sides, and x would equal -2. So my solutions are -9 and -2.